Swayam Prabha. Digital India. Educated India.
Now, the question is, the problem unfortunately is that this is in general not the case. In general, V upper bar will not be equal to V lower bar. Okay. So, as I was saying that if these two end up being equal, then it would be that each player's projection about the worst case actually in short comes true, right. So, we can formalize that by through this concept. So, suppose let I star j star be for player 1 comma player 2 such that A I star j star. Okay. So, you look at A I star j star, which this is what is this quantity here? This quantity is the payoffs that the players would get when they each play I star and j star. Okay. Okay. Let I star j star be strategy such that A I star j star is less than equal to A I j star and also greater than equal to A I star j for all I and j. Okay. So, what does this mean? That means that I star j star is such that when if you look at it from the point of view of the row player here, okay, so there are two inequalities that I star j star satisfies. I star j star has this property that if you look at it from the point of view of the row player, then assuming the column player is playing j star, the row player responds with I star, right. Is the best thing for him to do is to play I star, and likewise assuming the row player plays I star, it's the best thing for the column player to do is to respond with j star. Is this clear? So, if you have these two if I star j star are if a pair of strategies is like this, that satisfies this, then I star j star are called a saddle point. Now, okay, so this pair is called a saddle point. Now, I have used the notation I star j star for security strategies. I am also using it again for saddle point, and the reason for that is, see, if the security strategies together ended up forming a saddle point, then you would have that then they would actually suffice to solve the game, because effectively it would mean that each player when playing his security strategy, the other guy responds also with a security strategy, right, because the response to I star is j star, then the response to j star is I star. Okay. Now, so if you could find such a pair I star j star that satisfies this is called a saddle point. If you could find such a pair, then this would actually end up solving our problem. Alright. So, we will let us actually prove that. So, theorem is this: let A be so suppose let A be a matrix game such that V upper bar is equal to V lower bar. then 1, then A has a saddle point, okay, and B second the saddle point comprises of security strategy. You can write out another part of this, that if any pair of security strategies is a saddle point. Okay, all right. So let us let's go about proving this. Okay, so we already know that there always exists security strategies. Now, what we are going to show is that if V upper bar is equal to V lower bar, then you put together the pair of security strategies, they automatically form a saddle point. Okay, so that will then show that A has a saddle point, and secondly it will also show 3, which is that any pair of security strategies is a saddle point. Is this clear? Okay, so that's what we are going to show. Okay, so now remember we already know that V upper bar is always equal to V lower bar. What am I writing? We know that V upper bar is greater than equal to V lower bar. Okay, so which means that we know that max over J A I star J is greater than equal to min over I A I J star for security strategies I star and J star. Okay, but now what have we been given? We have been given that these two are in fact equal. Okay, we always know that there is a greater than equal to, but we have been given V upper bar equals V lower bar. That these are equal. Okay, that's what we've been given. So which means what? Therefore, we have max over J A I star J is equal to the min over I A I J star. Okay, so these are, remember, I star and J star are security strategies. Now, what I need to show is basically that this actually I star J star in fact form a saddle point. Okay, so how do I show that? Well, remember, min over I of this is always less than equal to A I J star, and max over J of this is greater than equal to A I star J. Okay, so now if I put, and so this is true for all I comma, this is true for all I comma J, which means what? Now if I put I equal to I star and J equal to J star, what would I get? I would get equality throughout. I would get A I star J star is equal to V upper bar A is equal to V lower bar A is equal to A I star J star. Alright. Now, what this in particular means, now remember what was V upper bar A? V upper bar A itself was equal to the min over I max over J of aij. Alright, so in other words, this was always less than equal to max over j and V lower bar A is max over j min over I aij. So therefore, this was always greater than equal to min over I for all j. Okay, but now what we showed was actually these are each equal to ai star j star. Both of these are equal to ai star j star. So therefore, now putting this is true for all I and for all j. So I can write this for all I, for in fact for I star and j star. So what would I get? I would get therefore a I star j star equal to putting these two together gives me. So this is the minimum over I of aij star. So therefore, this is less than equal to aij star for all I and also greater than equal to ai star j for all j. So actually, I don't need this to be less than equal to the point. I actually need just this this in fact to be out here. All I need is that this is in fact the max over j of ai star j, and this is min over I of aij star. Is this clear? So I just showed that V upper bar, V lower bar are both equal to ai star j star, and because they are themselves equal to max over j ai star j and min over I aij star, that then gives me this inequality. Okay, which means that I star j star is a saddle point. Okay. So what has this shown? This has shown that both this as well as this. So it is shown that A has a saddle point. It has also shown that you take any pair of security strategies, they will necessarily be they necessarily form a saddle point. You actually get one more thing for free here, which I have not specified, but that it tells you that actually when there is a saddle point, right, these V upper bar and V lower bar are in fact functions of just the matrix and not the saddle, and doesn't matter what the saddle point is. Whichever saddle point you choose, okay, if there is a saddle point, whichever saddle point you choose, the value is always going to be V upper bar and V lower bar. Is this clear? So V upper bar and V lower bar were defined from security strategies, and therefore they were functions of just A. The saddle point was just defined abstractly as a bunch of inequalities. So there is no guarantee that the value of that saddle point has to be the same for every saddle point. But we are getting that for free. That whenever there is a saddle point, it will always be equal to this particular value. Okay. So alright, so let's actually show the part 2 here, which is that a saddle point comprises of security strategies. Alright, so now what is the definition of a saddle point? Saddle point is a point I star j star such that I star j star, if I star j star is a saddle point, then this must hold. Now, what we will show is, we will show that I star J star are security strategies. Okay. So, how do I argue this? From this inequality, I want to argue that I star J star are security strategies, which means I want to argue that I star is the one that minimizes the worst case damage for the row player, and J star is the one that minimizes the worst case damage for the column player. So, how do I argue that? So, you could try by contradiction. There is a simpler argument here. So, if you actually look at just this part, right. So, this is in fact the interesting thing about zero sum game. See, if you look at these in isolation, any of these in isolation, look at this inequality in isolation or this inequality in isolation. This is only saying that I star is the best reply to J star, and this is saying that J star is the best reply to I star. It does not actually say that these two are, we are not really using the fact that these two hold simultaneously. This is just saying that each player is responding with his best reply, okay. But that they end up giving the same value is not actually being used here, okay. So, if you want to get back the security concept, right, then you have to use that, you can't use, it's not enough to use any of these in isolation. You have to use the entire chain of inequalities, which means that you have to use that this left extreme is actually less than equal to the right extreme, okay. Now, what does that mean? That means that AI star j is less than equal to AI j star. Okay, AI star j is less than equal to AI j star. So, but then what is AI j star? That is in turn less than equal to that is in turn less than equal to the max over j Aij, right? The right hand side is not, okay, I should, maybe I will make it easier, I will first do this. So, this is the left hand side is a function of j, the right hand side does not have j, it has only j star. So, I can say, well, therefore, max over j of ai star j is less than equal to ai j star. But aij star is itself less than equal to max over j of aij. And so, therefore, you get that max over j of ai star j is less than equal to max over j of aij, which means that I star is a security strategy. So, this one here, I can observe that in this, from this inequality, from the first inequality here, left hand side is now not a function of I and the right hand side is a function of I. So, I can do a min over I over there, min over I j star, and the left hand side will still remain I star j, but then that is in turn greater than equal to min over I aij. Now, combining these two tells me that j star is a security strategy. In other words, there is really, once the V upper bar and V lower bar are equal, there is no difference between saddle points and security strategies. Conversely, if a saddle point exists, then automatically you will get for free that the V upper bar and V lower bar are equal, because the saddle point has to comprise of security strategies. Okay. So, if there is a saddle point, they comprises of security strategies, and you will get that yeah, the saddle point value is actually equal to V upper bar and V lower bar. Okay.